Hello students, welcome back to Picture Foundation. Students, in last class of vectors, we did questions based on scalar triple product. Now in today's class also, we will do some more questions based on scalar triple product. So let's start the class. Question is, if A vector is equal to A1 I cap plus A2 j cap plus A3 k cap, B vector is equal to B1 I cap plus B2 j cap plus B3 k cap, and C vector is equal to C1 I cap plus C2 j cap plus C3 k cap. Then prove that box of NE plus B, NB plus C, NC plus A is equal to N cube plus 1 times determinant of E dot I, E dot J, A dot K, P dot I, P dot J, P dot K, C dot I, C dot J, C dot K. We have to prove this. Okay. Now let's start. Okay. Now start with LHS. So that is box of NA plus B, NB plus C, and NC plus A. Now using property, this box can be written as box of NA, NB, NC plus B, C, A by splitting. Okay. After splitting, we would have 8 determinants, but out of these 8, out of those 8, 8 would be 6 would be 0. Right. Now in first box, uh, these 3n will come out and will become n cube, and n cube times A, B, C plus this box BCA can be written as again ABC, box ABC. Right. Now these are all vectors. Right. Now if I take box copper, then this will remain inside n cube plus 1. So n cube plus 1 times box of A, B, C. Now this box can be written as determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay. And also this A1 can be written as A dot I. Okay. And A2 can be written as A dot J. And A3 is A dot K. Similarly, B1 is B dot I, B2 is B dot J, B3 is B dot K, C1 is C dot I, C2 is C dot J, and C3 is C dot K. And this is our RHS. So this proved, hence proved. Now this is done. Now let's come to next question. Question is, prove that any vector R can be written as a linear combination, a linear combination R vector is equal to box RBC by box ABC times A vector plus box RCA upon box ABC times B vector plus box RAB on box ABC times C vector. Okay, now this we have to prove. So here there are four vectors basically: R vector, A vector, B vector, and C vector. Right? R vector is equal to x times A vector plus y times B vector plus z times C vector. Okay, because um, these four vectors are in space. Okay, now if I take dot product with A cross P, then what will become? R dot A cross B. I'm taking dot product with A cross B both sides. So this will be x A dot A cross B plus y B dot A cross B plus z C dot A cross B. Okay. Now R dot A cross B can be written as R A B box R A B, sorry, is equal to A dot A cross B is 0 because A vector and A cross B vector are perpendicular. Similarly, P dot A cross B is also 0 because P vector and A cross B are perpendicular vectors. And this C dot A cross B is nothing but box C A B. Right? Now from here we can get Z. Z is box RAB on box CAB, or this box CAB can be written as box ABC. Now we have seen Z times this box is containing CAB, right? So similarly I can say Y will be box R RBC. Similarly X can be box RPC after taking dot product with P cross C upon box ABC. Okay, and Y is equal to box RCA upon box ABC. Okay, so therefore now R vector becomes box RBC upon box ABC times A vector plus box RCA on box ABC times B vector plus box RAB on box ABC times C vector. Okay, this is root, which is RHS, right? So Now come to next question. Question is express A vector in the form of B cross C, C cross A and A cross B. Okay. Now again, this question is of last type question. Okay. So because these four vectors again are in space, so any vector can be represented as a linear combination of the three. So we can write A vector as x times B cross C plus y times C cross A plus z times A cross B. Okay. Now, because we have to in this question also we have to make a box. So for making box, also for finding x, y, z, we can take dot product with A vector, B vector, C vector one by one. So now taking dot product with A vector, so A dot A is equal to x times A dot B cross C plus this will be 0 and this will be 0 because A vector and C cross A are perpendicular and A vector and A cross B are also perpendicular. So dot product will be 0 because cos 90 is 0. So from here I can get x is equal to mod of A vector square upon box ABC, right? Similarly, E dot B is equal to 0 plus 5 times B dot C cross A plus 0. So from here y will be A dot B on box of BCA, which is box ABC because order is not disturbed. Okay, and A dot C is equal to 0 plus 0 plus z times C dot cross B. Okay, so from here we can get z is equal to A dot C on box ABC, right? So A vector becomes x times B cross C. So x is nothing but mod of A square on box ABC, and in all these x, y and z denominator is same, so I can write 1 upon box ABC times mod of A square times B cross C plus A dot B times C cross A plus A dot C times A cross B, right? So this is required form. Okay, this is final answer. Okay, now let's come to next question. Again, I am taking question of the same type. Question is express B cross C in terms of A, B, C, right? So now let B cross C is XA vector plus YB vector plus ZC vector. Again, I have to find these x, y and z, and question is of the same types. We have to make box again. So how we can make box? By taking dot product, right? So if I take a dot product with P cross C, C cross A and D cross B one by one, box will be appeared. So let's start now. Taking dot product both sides with P cross C. So P cross is already and dot P cross C. So XA dot P cross C, and second and third will be 0 because of perpendicular case. So X becomes mod of P cross C square upon box ABC. Similarly, Y can be P cross C dot C cross A. If I'm taking dot product with C cross A, so this will be in denominator, because first term and third term will be 0. A dot C cross A is 0 and C dot C cross A is 0. So this will be B dot C cross A and B dot C cross A is box ABC. Okay, B dot C cross A is. Now let us take another question of different type. Question is, if U vector, V vector and W vector are three non-coplanar unit vectors having angle alpha, beta and gamma, and X vector, Y vector and Z vector are unit vectors of angle bisectors of alpha, beta and gamma, then prove that box of x cross y, y cross z, z cross x is equal to 1 by 16 box of u v w times sec square alpha by 2 sec square beta by 2 sec square gamma by 2, right? So we have to prove this thing. Now let's start. So it is given that alpha, beta and gamma are the angle between u, v and w. So this alpha is u vector cap v vector, beta is v vector cap w vector and gamma is w vector cap u vector. But thing should be but this thing should be kept in mind that u, v and w are unit vectors. You can write u cap as well. So also I am showing this thing diagrammatically. If this is u, this is v, this is w, so this is alpha, this is beta, this is gamma. Okay, and alpha, beta, sorry, and x, y and z are unit vectors of alpha, beta and gamma. So this is x, this is y and this is z. So x vector, y vector and z vector. So x vector is lambda times u vector plus v vector upon lambda times mod of u vector plus v vector, because x vector is unit vector. So I am dividing by modulus of u plus v. So, and also we know very well u and v are unit vectors. So x vector can be written as u plus v upon 2 cos alpha by 2. Reason is mod of x cap plus y cap is 2 cos theta by 2, where theta is the angle between x cap and y cap, right? Similarly, y vector is v plus w upon 2 cos beta by 2, and w is z is w plus u upon 2 cos gamma by 2, right? Now from LHS, that is box of x cross y, y cross z and z cross x, right? Now this box can be written as box of x, y, z whole square, and I am having x, y, z in terms of u, v, w, so I can place this in place of x, y, z. So x is u plus v upon 2 cos alpha by 2, y is v plus w upon 2 cos beta by 2, and z is w plus u upon 2 cos gamma by 2, right, whole square. Now I am taking denominator out. So in row 1 there is 2, in row 2 there is 2, and in row 3 there is 2. So in denominator or from denominator there will be outside 1 by 8 square, because box is having square, and 1 upon cos square alpha by 2 from row 1, cos square beta by 2 from row 2, cos square gamma by 2 from row 3. Okay, this will be u plus v plus w plus u in box whole square, right? So this will be 1 by 64 sec square alpha by 2 sec square beta by 2 sec square gamma by 2, and u plus v plus w plus u can be written as 2 times box of u b w, and cos of square this will be 4 outside, 4 times u v w whole square. Okay, then 4 16 ja 64, so 1 by 16 sec square alpha by 2 sec square beta by 2 sec square gamma by 2, and box of u v w whole square, and this is required RHS, hence proved. Okay, now let us understand the concept of distance between two lines or distance between two skew lines using box. So write down the heading: distance between two skew lines. Let us take line 1 as r vector is equal to a vector plus lambda times p vector, and L2 is r vector is equal to p vector plus mu times q vector. And from formula we have seen earlier, for distance between skew lines we can write d as a minus p dot p cross q upon mod of p cross q. Okay, now we all know that dot product is distributive over addition or subtraction, so I can also write this thing as a dot p cross q minus p dot p cross q upon mod of p cross q. Okay, now a dot p cross q becomes box apq, box apq, and p dot p cross q becomes box ppq on mod of p cross q. This is required distance between skew lines in terms of box. But also I am interested in finding the condition for intersecting lines. So if L1 and L2 are intersecting, then distance between these two will be 0, or you can say box of APQ minus box of PPQ will be 0, or box of APQ is equal to box of B PQ, right? This is the condition of intersecting lines. So students, for today's class we are done. Let's meet in next class. Till then, bye bye and take care.